When we see a product, we only see the final creation, and oftentimes, it's all we really come for. Most people in the world never think beyond what is behind the scenes, and we're generally not supposed to, because consumerism demands that we take the finished product and move on. However, there are those that have went through the curtains and have seen what is on the other side. That other side is full of abstractions, mathematical equations, and lines of code that run the systematic process of the product's development. In the case of gaming, we have more than we could have ever dreamed. Seeing a marriage of the old and the new, being propagated by both AAA studios and the sea of indie studios or solo developers. The methods behind the same scenes are more dynamic than before too, using large game engines, smaller minimalistic engines, or being created from scratch with nothing but lines of code, supported by frameworks containing libraries and additional tools to get the job done. The level of variety, however, can only be appreciated behind a computer screen, with enough processing power and a decent enough graphics card to create more intensive projects. Whatever decade of programming and game development you look at, you will find a number of commonalities between them. The advancements of languages, libraries, frameworks, engines, and the advancements of hardware and existing products to push the boundaries of development further. Now, we seem to be in an infinite bubble where the scale of projects can shift from pixelated works of art to photorealistic works like you would see in the Unreal Engine, a thing that it is most well known for nowadays. In my previous video, I dived into the world of fantasy consoles, a subsect of indie development that created platforms that replicated a period of early gaming, while also adding an engine of their own for players to develop their own games. In this video, I will be diving into another specific category of game development, something that's been done for a very long time, and is still practiced by many developers that wish to cultivate a more fundamental understanding of how programming works, and what really goes on behind the game engines that we use today. I am referring to the realm of games made without engines, in favor of using frameworks like Pygame or Love2D, or built from scratch using just the language of choice, alongside additional tools. But first though, I will delve more into game engines, with what I know about them and what they do for the industry. Mind you that my knowledge and experience on this whole subject isn't quite as extensive as others, and I may also get a few things wrong here too. But game development is something that I've personally been interested in for a very long time, and the development of games without the use of game engines is a very interesting part of programming and game development that I feel is worth talking about. So here we go. To start the subject of game engines, we need to talk about the two elephants in the room, Unity and Unreal Engine. As of now, these are the two biggest game engines in both the AAA and the indie industry. Both platforms share an ocean of players and developers, where players try out their games or aspire to become developers. Developers in turn provide projects from small to big that only enrich the library of these two engines. Unity has come a long way since, and is easily the most flexible one out of the two, while Unreal generally fulfills a category where photorealistic looking games are generally the norm, with some exceptions of course. Unity can be morphed into anything project-wise, from pixel art goodness to PSX inspired graphics, as well as games closer to real life. It's the most accessible and flexible engine out there today. Unreal Engine though is something more geared towards, like I said, photorealistic graphics. And also not to mention, the Unreal Engine generally revolves around shooters or action games. Both engines have had a huge impact on the gaming scene, and for the most part have done wonders for both gaming and the gaming development community. But in saying that, there are lots of developers within the development stratosphere that ultimately reject these platforms in favor of either other game engines, other frameworks, or come to the decision where they need to make their own game engine. Some AAA studios have made their own game engines as a result of making it far easier to implement the desired mechanics within their project, as well as avoiding the royalty fees that both Unity and Unreal put on you when your project becomes too successful. Capcom have their own engine called the RE Engine, also known as Reach for the Moon, which you can see in the recent Resident Evil releases. id Software have the id Tech engine, which they've been improving upon each generation of gaming, making new iterations each generation. Bethesda Studios had the Game Buyer engine and slowly converted it into the Creation engine, which is what you see in games like Skyrim and Fallout 4. It's an engine that they have been modifying and improving upon since the early 2000s, and Starfield is supposed to get another version of the engine, Creation Engine 2. Valve has the Source Engine, a truly unique system that has created some of the most iconic PC releases of all time, and is also a platform that has spawned so many other creations in both the modding and the animation scene. DICE with their Frostbite engine never ceases to amaze me with its close to real life graphics like in the recent Battlefield entries and even Battlefront 2. Other studios like the studios behind Call of Duty, Rockstar and Ubisoft all have their own game engines, and they all have their own unique distinctions between each other that are reflected upon the games that come out of it. As for the likes of indie developers, the engines are generally on a scale that is workable in their own workflow, and is enough to make the games that they want. When Unity or Unreal just simply won't cut it, they usually end up making their own engine. There is generally a lot more work involved, even more so than making a game within another engine. But the purpose of making your own engine is usually to have 100% authority and control over all of the elements that comprise the engine. Whereas with other pre-existing engines, there is only so much you can do to modify those elements, and the nature of their workspace and their components may make it difficult for a certain mechanic or concept to come to fruit. Making your own game engine makes room for more unique ideas or mechanics that other game engines may not be able to accommodate for. The creators of Fez and The Witness made their own engines as a result of having more control, as well as making it easier to implement their own unique mechanics, which ultimately paid off for each respective creator. Outside of the realm of Unity and Unreal, there are a plethora of other game engines that also exist. Some come with subscriptions, a one-time payment, or a 100% free and open source. They also come with different languages chosen for the creation of said engines. Default Engine is a 2D-centric engine with some 3D capabilities, written by Lua, an easy and accessible programming language to use. Also used to make one of the biggest platforms ever made in gaming history. Roblox, where a number of incredible creations come from that a lot of other people don't realize is Roblox. Default, on the other hand, is a great starting point for those wanting to make smaller or mid-sized games with graphics that don't push the hardware too much. It's also very lightweight, can be modified with extended code as well as tools to make the engine cater more to your liking. There are also other platforms like GDevelop and ClickTeam Fusion that are also good choices that are very accessible for people wanting to get into game development, but don't necessarily enjoy coding too much, and want to avoid it entirely if possible. But the thing is, if you want to evolve in your time as a game developer, you will need to learn how to code. Learn a language so that you can make bigger and more ambitious projects in the future, all the while having a better understanding of what you're doing and why it does what it does. The other game engine, and one that I think is the best alternative to Unity today, is Godot. It is an engine that has been in the works since 2014, and they just rolled out with Godot 4, bringing many quality of life changes to the existing elements in its scripting, rendering, and tools that give developers of Godot a better time in the engine overall. Unity is great and all, but it's also a big boy in comparison when it comes to install sizes, something that Godot doesn't have an issue with at all. The executable file for Godot is only in the megabyte range, which is honestly insane given how sophisticated it looks once you reach the scene editor. Games like Amnesia: The Dark Descent, No Man's Sky, and Overgrowth all have their own engines. The games that use their own engines generally stand out more in comparison to lots of other games that you'd find in Unity and Unreal, because the efforts to compiling and writing the code to create their own custom engine also gives the game a unique identity of its own. Even look at the games made by Valve or Ubisoft and you will see huge differences between the two. People that use Unity or Unreal have to make up for it with different spins on existing game concepts as well as ideas in implementing unique art styles as well as new mechanics. There's a very good read that I found on GitHub that goes into more detail about the subject of custom game engines. I'll provide a link in the description for them. There are lots of other game engines, and some that are incredibly ancient now, like the Spring Engine, which is mostly known for large-scale strategy games like Total Annihilation and Supreme Commander. Ogre 3D, Panda 3D, Copper Cube, Game Maker Studio, Game Guru, and even RPG Maker are still being used today, each having their own core strengths and weaknesses, as well as having a general pattern of what kind of games are made for them. I'll provide a list that comprises all of the known game engines that you can have a look at. But if you're looking for a game engine, then personally I would recommend either Unity or Godot. They're both really flexible, you can make a variety of different games with them, Default is another good option too, especially if you want to work more with the Lua language. Otherwise, just focus more on learning programming and game design and use whatever tool or engine that suits your workflow and preferences. Now, I want to make clear here that I'm not a veteran coder or developer and don't have a lot of experience in either department, but I'll explain what I can within the context of game development. No matter where you start or what language you decide to learn first, it's going to be incredibly overwhelming, even with something like Lua, which is one of the more simpler languages to learn. The same goes for C due to not having OOP, which is object-oriented programming, since C is a procedural and structural based language. Marrying the two different levels of languages, high and low, will give you two different perspectives within the coding world and game development. What you do in languages like C will have different uses compared to other languages. A language like Go is often used for server-side programming. JavaScript and HTML5, the serial killers behind the murder of Adobe Flash, are used for a lot of web-based applications. C++ and C# are great for more intensive programs, especially C++, which Unreal Engine uses. And Godot also supports it, which can really optimize your projects on that engine to run even better, provided that you've written code that won't backfire on you later and your memory allocation game is on point. There are these people, Windows users that use Swift, and Java. The reason why I can crank out tunes from RuneScape when I'm out leveling my woodcutting skills to 99. There are, however, modified languages or custom languages that are offshoots of existing languages. GDScript from Godot is a modified version of Python, one of the most widely used languages in IT, and is commonly used for AI and machine learning. There is CubeScript for the Cube 2 engine, most notable for the arena shooter or platform known as Cube 2 Sauerbraten. Even the idTech engine has also used existing languages and has modified them or made its own to fit the new edition of each engine. What they all have in common is that they all give commands based on the variables, statements, and functions that are put together. The end result for each project or software product is done through the abstract nature of programming languages, supported by the frameworks and libraries that correlate with their respective languages. It's been puzzled over, interpreted, and expanded upon since the early days of computer science and programming. Game development has benefited from the continual evolution of software, hardware, and further creations of tools, frameworks, libraries, and subset systems that coincide with the game engines. The same engines that I've mentioned that have brought to life so many games that have either become success stories or have just added more water to the giant sea that is gaming. Recent developments, however, in visual scripting have given other people that can't get over the abstract composition of coding a more logic-based approach to game making. Unity and Unreal also have blueprints that enable visual scripting, and it's improving each year. GDevelop is an engine that is mostly visual scripting, that does also support traditional coding, by allowing JavaScript blocks into a project that can make your GDevelop project more of a standout. But visual scripting for the most part will give you more of an automatic approach to making games since it'll be easier to read. However, in saying that, you don't have the same level of control and more complex applications are harder to work on when applying visual scripting, something that traditional languages are more agile and flexible with. Not to mention too that even with visual scripting, using nodes for blueprints, you still need to utilize the mouse and keyboard, typing in variable names, function names, numerical constants, but in a visual manner, as well as adding comments that explain what you're doing. You can pretty much do all of that with just a quick line of code in an IDE or a text editor. Now, it's still possible to make games with visual scripting like you can do in Unreal or GDevelop, and if that's all you want to do, then that's fine. But like I already said, if you want to work on more sophisticated projects while giving yourself more flexibility and control to implement new mechanics, functions, and new abstractions, then learn a traditional programming language like C++ or C#. Now, this is going to be in contrary to the subject of the video, but it is an unavoidable fact and I had to make sure the distinctions were clear before making this video. Game engines are also in fact frameworks, but built upon with the addition of editors and other core engines that relate to physics, math, and rendering. Unity and Unreal have enough to identify it as a game engine, but the support structure and various libraries that make up a framework also make game engines a framework. But not all frameworks are game engines. So what are frameworks exactly? Well, it's a structure containing libraries which contain pools of data ranging from programs, subprograms, objects, functions, and more. It creates an environment for the programmer that makes it easier to execute the code needed for their project. and there are different frameworks that exist for different avenues of development. Just about every programming language has a framework written for it which contain their own libraries. You have the Spring framework for Java and
Kotlin,
which is great for enterprise applications. The Django framework for Python, when you want to build large-scale web-based applications. You also have Angular, another popular web application framework written in TypeScript. They all create a space that makes coding more effective and efficient in their respective languages, in order to make the best possible applications. And the same goes for game development too. But in game development, the frameworks were eventually built upon to the point where they became something else entirely. Game engines, like you see in Unity and Unreal. But as I've already said before, there are those that work with existing engines, make their own, or work within the frameworks and their supported languages instead, where they have far more manual control into what gets implemented and what gets written. So you may ask, why not just use a game engine if you just want to make games? Well, there is nothing stopping you from doing so, and there's no right or wrong answer in either choosing a framework over a game engine. But there is a huge difference in regards to understanding and viewing the language itself. The game engines have a lot more autonomy because of the code written to implement the systems laid out already for you, coming packed with editors, its own code space to write your scripts, as well as implementing engines pertaining to math, physics, and rendering, which are already within the game engine. With building a game from scratch using frameworks or libraries, there is far more manual labor in order to get those systems running to build your game. With building upon each block, you can see behind the scenes as to why the physics engine, the math engine, and the rendering engine work the way they do. The best analogy that I've found from videos that talk about their preferences of using frameworks over game engines is this. A person using a game engine is sort of like a mechanic driving a car but not knowing how to build one from scratch. Building games in frameworks do require more work, but give you more flexibility and freedom into what functions can be called, what mechanics can be implemented, etc. The same goes for writing games entirely in code, which was what was done back in the 80s and onwards for a period of time, when there weren't really any game engines to develop anything on. Now, I don't mean to say that all users of game engines don't necessarily know how to build their own, as well as knowing how a game engine works. But people that gravitate to game engines generally only have the singular interest of making games. People that use frameworks or just the language itself in order to make a game will generally have a better understanding of what the code does, how the engines work, and why they work that way. Going through this approach is better for those that want to learn more about programming and computer science, while game engines are great for those that are mainly interested in making games. But if you're setting yourself up for a lucrative job in IT, then learning to make games through using frameworks will be a more beneficial choice for you, and will in the long run make your skills as a programmer more transferable across different applications. Using a game engine will get you more experience within their respective workspaces, but there's a limit to that, and if you get too comfortable with their built-in systems, it could eventually cultivate bad habits in creating clean code, and ignoring the back-end aspects of those systems and understanding the why and the how behind them will ultimately limit your growth and knowledge as a programmer and software developer. Now, there are several frameworks and even game libraries that you can use to get started. I'll go over some of them and talk about what I know about them and show some games made from them. Pygame is a game development framework made for the Python language, which was based upon its precursor PySTL, and has been improved upon since the early 2000s. It uses a combination of C and assembly code for core functions, uses STL library for rendering, and is very lightweight to the point where it can be used in the command line. Can also be integrated into other text editors and IDEs like Visual Studio Code, Notepad++, or Atom. It has a huge community and tons of resources to get you started, and is supported by a language that is more accessible to get into than something like C++. Pygame allows you to tip your toes into whatever genre you want, but its graphical performance is something that does leave a lot to be desired. The reason why lots of people use game engines is because the components that enable hardware acceleration rendering alongside the CPU are generally more powerful. You won't be able to make something that is just as photorealistic to the extent of something like the Unreal Engine. But that's not to say that you can't make great looking games on Pygame. You can bounce from early 3D looking graphics to vectors and pixel art, which is generally utilized the most in Pygame because of how many layers of it you can use. There are some misconceptions, however, regarding the performance of Pygame. There is a very good video that provides clarity on the subject. I'll provide a link for it in the description. But two important notes that I found in it is that the performance is often associated with the way that your code is structured. If it's designed and structured poorly, then the project will run significantly slower. Also, using .convert when you load your images in Pygame will improve performance greatly. And if you want to expand more on its capabilities, you can also utilize other libraries as well as using something like Cython, allowing Python code to be translated into C code, which also enables the programmer to gradually add C types and functions within their project. But if you're looking to make a 3D project, you may be better off looking elsewhere. While it's capable of 3D applications, it's also pretty limited, and performance is pretty bad due to only being able to process and execute a certain amount of layers, something that pixel art is more flexible in. If you want 3D alternatives to Pygame that do a better job, then I would look at the Ursina or the Panda 3D engine. They perform a lot better in regards to rendering 3D graphics, and may be a better fit for you if your goal is centered around 3D applications. Otherwise, Pygame is a really good starting point for learning Python and game development at the same time. Also, for a lot of the projects, you can also read through the source code as well, to get an idea of what the game looks like behind the scenes, which goes for a lot of these projects across different frameworks and libraries. Love2D is another framework similar to Pygame, dating all the way back to 2008, but it is written in C++ and scripted in Lua. Like Pygame, a lot of projects that come out of it are pixel-based and seem to operate in the 2D spectrum, since it was made to be a 2D-based framework. There are, however, libraries that enable 3D development within Love2D, and there's even one called Lover, which enables VR development. I'll provide links in the description so that you can find these libraries, and I'll do the same for Pygame as well as alongside the other ones that I'll get into later on. The appeal of Love2D is the use of Lua, a scripting language that is easy and accessible to use. Many games and mods have used Lua for scripting, and one of the biggest platforms out there, Roblox, was built using Lua. Love2D's lightweight frame makes it a great entry point for people wanting to use a less intimidating language like Lua in order to get into game development and programming. It uses the OpenGL library in order to render the graphics, where it pulls from the GPU more than something like STL, which focuses more on the CPU. In saying that, the code written will also affect performance, as most of the games I've seen on Love2D can also be done in Pygame. Neck and neck, they're similar, albeit with differences in their libraries and languages. They're both pretty flexible, and with some smart application of pseudo 3D in the code, you could even make something like GTA 2 within Love2D. People have even recreated Minecraft in Python. So what that should tell you is that these two frameworks do have a lot of power, and it is possible to make some really interesting projects. But they can only be properly utilized by knowing the language and knowing how to structure the code properly within the respective framework you're using. But like Pygame, Love2D also has a big community behind it, and there are tons of resources to get you started. Raylib is a library geared towards making games or graphics-based applications, written in C and has also been ported to many other languages, where you can use different versions of Raylib, which I'll also provide in the description. Its simple and easy to use structure also makes it another accessible starting point for people wanting to get into games. It's also used quite often in GitHub and is even utilized outside of game projects. Its main concept is that it strives for simplicity. Mind you though that the word simple in the world of game development and programming means that there are easier methods to getting the job done. But even the easiest way of doing it is still harder than eating and walking, so good luck. LibGDX is another framework written in Java, you know, the language that made these two, but it's also written in C and C++, more specifically for performance-dependent code. This framework is often used for mobile games. In fact, a lot of mobile games that you may know about were probably made in LibGDX. Slay the Spire, one of the most successful indie card games in 2019, was also made with LibGDX. The performance for the games I've tried were great, and has a diverse range of different genres with different art styles to enjoy. Are you going to be able to make something like in Unity or Unreal's level with highly polished graphics and detail? Maybe not, but that's not to say that Raylib and LibGDX aren't capable of producing great games. It's just that lots of developers will generally move on to something more powerful like the game engines I just mentioned. Raylib and LibGDX are incredibly lightweight, are workable even on lower end PCs, something that may make the use of frameworks more accessible if your computer isn't necessarily up to snuff for higher end game development. LibGDX's API also enables cross-platform development, meaning that you can deploy your game across many other platforms, ranging from Windows, Linux, Mac OS, Android, iOS, the web, and even Raspberry Pi. Raylib is great for lightweight game development and LibGDX is great for mobile development, but also viable for desktop applications. JavaScript makes up the backbone now of many web-based applications across the internet. It's one of the most sought-after languages across many departments in the IT world. But it's not often associated with game development because most of the other game engines or frameworks work with other languages geared towards game development. But that doesn't mean that JavaScript isn't capable of doing so. On the contrary, it's quite powerful in its own way. As you can see here with Three.js, a web-based library that can render 2D and 3D applications displayed on the browser. The vast majority of people that work with JavaScript also use Three.js to add to the portfolio, whether it be to showcase their work or get their foot in the door for working in the IT world. There are lots of amazing portfolios and applications that have been made with Three.js. Because of its browser-based roots, it uses WebGL to render the 2D and 3D graphics that you see, including libraries for math on top of classes, containing subclasses for light, mesh, and the cameras that you can see within Three.js. Compared to the other game frameworks or game libraries that I've mentioned, this one definitely has a bit more juice to work with, given its ability to render things like this, alongside great physics and tools to bring the most out of Three.js's ability to render beautiful looking 2D and 3D graphics. In saying that, you should only go for Three.js if your projects are going to be browser centric. What you can do here, you can also do in other game engines like Unity or Unreal, but with far more flexibility and rendering power. However, if you want a great library for JavaScript to build upon your portfolio, or want to work with applications that are powered by the language, then Three.js is worth having a look at. Game development is more accessible and easier to get into than it's ever been, and it's thanks to the creations set forth by passionate and talented people within the world of computer science. With the collective pool of engines, frameworks, and libraries, there are a large number of avenues to get yourself immersed into the game development scene, as well as the software development scene. But many people get into computing for a multitude of reasons, and in the case of game development, there are many ideas and concepts that are explored, or brought about in the many tools and applications used to bring these projects to life. Game engines are the most accessible method to creating games because of all of the essential building blocks that are already there for you. All you need to do is implement your assets and the code to make those assets snowball into the project that will come to be in the final product. Frameworks and libraries are also capable of doing the same thing, but there is a lot more manual work required, and you need a better understanding of the language you're using since it's not as streamlined in comparison to a game engine that already has things like a scene editor, a collision detection system, a math engine, a physics engine, alongside the powerful rendering capabilities that Unity or Unreal have. Frameworks are often sought by people that prefer a more lightweight platform, as well as having more control over their project and what goes into it like I said. There are developers that use frameworks and libraries as a means to brainstorm ideas and projects, all the while learning more about the basics and core fundamentals of the language they're learning. And other developers that use game engines for the most part use programming as a means to an end, and make game making the primary focus. Frameworks offer more insight into how programming works and how the languages are utilized into game engines because you're essentially working with a skeleton containing libraries and a few other things. But you have to add the rest through lots of coding. Game engines are the better choice if game making is your main goal, and if you're not too concerned about learning every aspect of the programming language and how it applies to other applications. Like I said, there's no right or wrong answer here. Both have their advantages and disadvantages, and if your game is going to be something on the likes of like Unreal or Unity, you may be better off going in that avenue. At the end of the day though, you will ultimately go with the platform that suits your project the best. I hope I've been informative enough to give you an idea of how frameworks and libraries are used in game development and how they differ from game engines and why some developers prefer to use them instead. There are a ton of other gaming frameworks, libraries, and game engines out there that you can find beyond the ones that I've already mentioned. This is a topic that I'm learning more about every day, and making a decision to make a video about it was a lot of fun. It was a lot of research though, and I've barely scratched the surface on everything I've just talked about. Like the video I did on Pico 8, I explored a different realm of game development that is both a departure and an older means of developing games. Before there weren't really any game engines. They had to use either text editors, libraries, or frameworks over time in order to develop the games as well as other applications. But now we have easier options like Unity or Unreal or Godot that make it far more accessible in comparison. As for what additional software you would need to make games, well, You would need software for modeling, drawing, music, as well as sound effects. Here are some fantastic free applications that you can use for a no-budget access to game development. As for using Unity and Unreal and other subscription-based or one-time payment applications, there are also great choices if you can afford them. Whatever path you choose in the world of game development and programming, just remember that they all have one thing in common. It's hard, and it can be overwhelming, but the reward and satisfaction of successfully completing a project is always worth it in the end, just like any other milestone. Thank you for watching.